Hi dear students, this is the third video about the probability, and we are going to continue with the estimating probabilities, and we are going to try to understand what is the difference between the experimental probability and the theoretical probability. If you remember, I said two types of probabilities there are. The first one was theoretical probability. Actually, in first video and second video, we studied about that one. And the second one is experimental probability. You're getting the results with respect to your experiments, or also each time drawing a pin is here. It is given the pin experiment. Each time when the pin is dropped, it is called trial. So when you roll the dice, if it is you're rolling dice, each time you roll the dice, it is called one trial. So all the results that you are going to list with respect to that one, total number of trials number of successful trials divided by total number of trials, it's going to give you the experimental probability. And I'm going to show here with this table what is the difference between the theoretical probability and the experimental probability. If you remember rolling the dice experiment, there are 6 possible outcomes, and we can show 1, 2, 3, 4, 5 and 6 with respect to number of spots to that one here. This is our here, and this is our, I want to move this one. I don't know why I cannot move here. Okay, now I can. Here I'm going to roll the dice, and again I'm repeating this one here. If there are 2 spots here, it's going to be 2, and I'm going to roll this dice 12 times, rolling a dice for 12 times. This is our experiment. In theoretical probability, since we know that for each one we have one possible case, when you have 6 totally possible case, you remember that it's going to be equal to 1 over 6. For the 1 over 6 is the theoretical probability. For probability of 1, let's say it is equal to 1 over 6. And if you make the trial for 12 times, of course this should be expected as 2 over 6. So theoretical probability expect that all of them, they are going to be 2 times. It's going to come 2 times and 2 times and 2 times it's going to be. So what is the experimental probability results? Here I'm going to roll 12 times, and I'm going to put tick for each time, and I'm going to see that how many times it's possible for each value. So first I'm rolling, it comes up 3, so I'm going to put tick for 3. One more time, so this time to 1. One more time, this time to 6. One more time, this time to 5. One more time, this time to 3 again. This is the second time 3. 6 again. 1 again. 5 again. 4 again. 6 again. 5 again. 1 again. Okay, so I think from these ticks we can easily count that we have 12 here. So I rolled 12 times and I got 3 times 1, 0 times 2, 2 times 3, and 1 times only 4, 3 times 5, and 3 times 6. When you add them up, 3 plus 3 plus 3 plus 3, 4 times 3, it's going to be equal to 12. So rolling a dice for 12 times in real life gives these results. And here we can say that probability of 1 is equal to 3 over 12 with respect to, this is the theoretical pardon, this is the experimental. Theoretical is 1 over 6, but the experimental probability results, I got out of the page, yes, experimental probability results here, it's going to be probability of 1 is equal to 3 over 6, probability of 2 is equal to 0 over 12, 3 over 12, probability of 3 is going to be equal to 2 over 12, probability of 4 it's going to be equal to 1 over 12, and probability of 5 it's going to be equal to 3 over 12. With respect to this one, to total trial I'm dividing. Here probability of 6 also it's going to be equal to 3 over 12. But these are the experimental probability results. What about the theoretical probability results? All they are going to be equal to 2 over 6, 2 over 6, 2 over 6, and 2 over 6 it should be. It may continue like that. Pardon, I'm so sorry. 2 over 12 also be. Here when you roll 12 times, the probability here, this is the theoretical part. Let me write with different color that one. If I continue with the theoretical part, theoretical probabilities results, they are not expected results, they are all certain results. For the theoretical probability of 1 it should be equal to 2 over 12, probability of 2 it should be 2 over 12, probability of 3 it should be 2 over 12, probability of 4 it should be 2 over 12. Actually probability of 1 is equal to 1 over 6 at the beginning that I showed here. Here you are going to simplify, and 1 over 6 it's going to be 1 over 6 it's going to be, so on. You can continue like this. All of them, they are going to be 1 over 6, 2 over 12, this is also 2 over 12, and 1 over 6 it's going to be. So that's the difference between the theoretical probability results and experimental probability results. Let's solve one more exercise to understand this one. Here I'm going to leave this one and look does an experiment to estimate the probability of drawing pin handing point up, and you know drawing the pin landing point up it will be, or there are two results, point up or point down. It will be point up or point down. So when you do this experimental, theoretical probability says that if you are doing this one for 10 times, 5 times it should be it should land up, 5 times it should land down. But here they count and they are recognizing that Luke does this experiment and he got 3 times up, and from out of 10 experiments or 10 trial. Okay, Rafael does the same experiment and he dropped 50 times and it lands 20 times. Actually, these numbers are suitable with the large number experiments, large numbers theory. I will explain later what does it mean if we have time. Okay, work out the experimental probability of drawing the pin landing up point up for Luke and Rafael. So if he makes this one, so let's do the A1. For Luke, let's do this one. For the Luke, he makes 10 times, the probability of point up is going to be equal to 3 divided by 10. For the Rafael the point up it's going to be 20 divided by 50. So who is most likely to have the better estimate? Give a reason for your answer. It says, firstly, the theoretical probability tells us 25 divided by 50. This is the theoretical probability results. So which one is closer to? This is 30 divided by if you multiply by 5, this is going to be, then you can easily compare. We are expecting 25 divided by 50, so this is going to be 15 over 50. This is the 20 over 50, and the theoretical probability expects, if you do this experiment 50 times, 25 times. So as you see, 20 over 50 is more closer to 25 over 50 than 15 over 50, which means the Lux experiment with a large number is more closer to theoretical probability. So I'm going to put tick here, and I'm going to give the answer with respect to that one. Okay, we are going to continue with the other exercises in the class.